Okay, now let's move over and look at the guided practice. So again, we're dealing with biconditional statements. So first they ask us to write the conditional and the converse within the biconditional. So remember, for a biconditional, it's written P if and only if Q. We have to turn this into the conditional, which is if P then Q, and the converse, which is if Q then P. That's our job. So which one is P? The first one. That's our P. Q is the last one. For a biconditional, this will always be the case. So let's write our conditional statement. If a parallelogram is a rectangle, then it has 4 right angles. Okay, so now let's flip that around. We need the converse first. Or we need the conclusion first for the converse. I can't talk today, evidently. So if a parallelogram has 4 right angles, then it is a rectangle. Now, they don't ask us to give truth values, so we're not going to worry about doing it. Okay, number 2, they ask us to write the converse and a biconditional statement, given the conditional. So that means the statement they give us is in the form of if P, then Q. We have to turn it into the converse, which remember is if Q, then P, and the biconditional, which is P if and only if Q. Okay, so let's identify our P and our Q, the hypothesis and conclusion. If 2 segments have the same length, then they are congruent. So two segments have the same length. There's our hypothesis. They are congruent. Is our conclusion. So now, for the converse, I have to say if Q, then P. Okay. So we'll say if two segments are congruent, then they, what's our P? Have the same length. Now they ask us for the biconditional. So that's the P if and only if Q. Well, let's draw our P first. Two segments have the same length. Then if and only if. And then what's our Q? They are congruent. Again, they don't ask for truth values here, so we're not going to worry about it. Okay, next one. They ask us to determine if each biconditional is true. If it's false, we have to give a counterexample. So remember, this is where we have to look at both the conditional and the converse. Let's get our P and our Q. So our P, an angle is obtuse. That means the Q is, its measure is between 90 and 180. So for conditional, we've got to do it if P, then Q. So if P, an angle is obtuse. Then Q, its measure is between 90 degrees and 180 degrees. Let's not worry about truth values right now. Let's get the converse. So remember, the converse is where you flip it. So Q comes first. If an angle measures between 90 degrees and 180 degrees, then its measure, wait, what am I saying? Then it is obtuse. I don't know where I was going with that. Now we have to look at truth values. So let's look at the conditional. If an angle is obtuse, then its measure is between 90 and 180. What do y'all think? What's it mean to be obtuse? You gotta be between 90 and 180. So that means this one is true. What about the next one? If an angle measures between 90 and 180, then it is obtuse. That's true. They're both true. So what's that mean about our whole conditional up here? That means it is true. And our last one for this lesson. We're doing the same thing that we just did. They give us a biconditional. We have to look at the conditional and converse to say whether or not it's true. So what's our P? A figure is a quadrilateral. There's our P. What's our Q? It is a polygon. So now let's write this into a conditional statement. Remember, that's if P, then Q. So if a figure is a quadrilateral, then it is a polygon. So that's if P, then Q. Now we need to do the converse. So that's going to be if Q, then P. So we switch. If a figure is a polygon, then it is a quadrilateral. Now let's talk about the truth value of each. So If a figure is a quadrilateral, then it is a polygon. Well, let's talk about definitions for a second. A quadrilateral is a four-sided shape. A polygon is just any shape with straight sides. So if it's a quadrilateral, then it's a polygon. Well, yeah, that's true. If a figure is a polygon, then it is a quadrilateral. So if we have a shape with all straight sides, does it have to be four-sided? No. It can be six-sided, for instance. So what's the name of a six-sided shape? It could be a hexagon. So since this one's false, what's that make our whole statement up here that we were given? False. Okay, so there's the guided practice. This is pretty much our last day as far as sentences go. So rejoice, rejoice. And now I get to work.